Now see next question, sub question fifth. If y equals to e raised to the power ax into sin bx, show that d2y by dx2 minus twice a dy by dx plus a square plus b square into y equals to 0. So here value of y is given and value of y in the form of product. So we have to apply product rule for differentiating the right hand side. So writing solution given part first. Y is equal to e raised to the power ax into sin bx. Differentiate with respect to x. So first we represent this y as equation number 1 for further calculation. So differentiate with respect to y, we get dy by dx is equal to, here we have to apply product rule. So first function into derivative of second, derivative of sin, we get cos. So cos bx and derivative of bx, which is b. Then plus second function into, that is sin bx into derivative of first. So derivative of e raised to the power ax is e raised to the power ax into derivative of this ax is a. So write this as b into e raised to the power ax cos bx plus a into e raised to the power ax sin bx. So here we can take e raised to the power ax common from both the terms from right hand side. So write e raised to the power ax in bracket b cos bx plus a sin bx. Now we denote this as, this is value of dy by dx. So we represent this as equation number second. Now we require d2y by dx2. So further we differentiate this equation number second with respect to x. So right here differentiate with respect to x. So derivative of y, we get d2y by dx2. Here we have to apply again product rule. So first function, that is e raised to the power x into derivative of this bracket. So while calculating the derivative of bracket, we have to apply derivative of first term plus derivative of second term, that is addition rule. So right here derivative of this bracket b into derivative of cos bx, that is minus sin bx into derivative of bx is b, then plus a into derivative of sin bx is cos bx. So right here cos bx into derivative of bx is b. So into b. So here we write first function into derivative of second function plus second function into. So second function is b cos bx plus a sin bx into derivative of first, that is derivative of e raised to the power x. So derivative of e raised to the power x is e raised to the power x into derivative of x is a. So here we multiply by e raised to the power x to this bracket. So we get here, so multiply by b into b, we get b square. So right here d2y by dx2 is equals to, in bracket, e raised to the power x. So we write this as minus b square sin bx. Then this plus ab cos bx plus ab cos bx. Then we replace the value of this b cos bx plus a sin bx into e raised to the power x from equation number second as dy by dx. So we write this as dy by dx into a. So we write here dy by dx into a from second. Now we have to prove here d2y by dx2 minus 2 times a dy by dx plus a square plus b square. Here we get only minus b square, that means we require here minus a square also. So for that, in first bracket we add and subtract a square term. So for that we have to take the value for which we have to take a common. So here minus b square sin bx, so we add minus a square bx. So see here what we have to do. E raised to the power x in bracket we add a square sin bx. We subtract a square sin bx. So this minus b square sin bx as it is, and this plus ab cos bx as it is, plus dy by dx into a. Here we add and subtract this term a square b sin a square sin bx and subtract a square sin bx. So we take minus sign common from second and third term. We write this fourth term at second position and multiply by e raised to the power x. So right here e raised to the power x into a square sin bx plus ab cos bx, and from these two we take minus sign common and multiply by e raised to the power x. So we write minus e raised to the power x into, here we get sin bx so we take here e raised to the power minus, we take minus sin bx common and multiply by e raised to the power x. So write minus e raised to the power x into sin bx. So in bracket we get plus a square plus b square here, then this plus dy by dx into a as it is. Now if you observe, this minus e a raised to the power x sin bx is value of y from equation number 1, and this bracket a square sin bx plus ab cos bx we take a common. So take a common again here. So write a into e raised to the power x in bracket. Here we get, if we take a common, so write a sin bx plus b cos bx minus e raised to the power x into sin bx into a square plus b square plus dy by dx into a. Now from equation 1 and 2 we substitute the value. So this e raised to the power x into sin bx, from equation 1 we replace by y, and this bracket, so this bracket a sin bx plus b cos bx plus a sin bx and into e raised to the power x. That means this term we replace by, this value in this term we replace by dy by dx. So right here a into dy by dx minus this value we replace by y into a raised a square plus b square plus dy by dx into a as it is. If we observe this, a into dy by dx and dy by dx into a are the same, so we add these two terms. So we get here 2 times a dy by dx minus y into a square plus b square, and this is value of d2y by dx2. So we transfer both the terms of RHS to left hand side so as to get this required answer. So see here, d2y by dx2 we keep in left hand side as it is, then we transfer this twice a dy by dx, then we get minus sign minus twice a dy by dx, and when we transfer this term to left hand side, this minus sign changes to plus. Here only we write y at last, so a square plus b square into y equals to 0. So hence in this way we show the required answer. So right here, hence proved. Now see question number 6. If sec inverse of 7x cube minus 5y cube upon 7x cube plus 5y cube equals to m, show that d2y by dx2 equals to 0. So we transfer this sec inverse to right hand side. So write in solution sec inverse of 7x cube minus 5y cube upon 7x cube plus 5y cube is equal to m. We transfer this sec inverse to right hand side. So we get here 7x cube minus 5y cube upon 7x cube plus 5y cube is equal to sec of m. Now sec of m, which is constant, so we represent this sec of m by any constant. So first we transfer this 7x cube plus 5y cube to right hand side, and this sec m we sec k. So write here k. Therefore 7x cube minus 5y cube upon 7x cube plus 5y cube is equal to k. We transfer this denominator to right hand side. So we get here 7x cube minus 5y cube is equal to, we transfer and multiply by k. So write here 7k x cube plus 5k y cube. Now transfer the terms of variable x to left hand side. So we write here 7x cube minus 7k x cube is equal to, we transfer this minus 5y cube to right hand side. So write here 5k y cube plus 5y cube. So here we take 7x cube common. So write here 7x cube in bracket 1 minus k, and here we write 5y cube common. So write 5y cube in bracket k plus 1, that we write 1 plus k. 5y cube 1 plus k. So transfer the variable term in one side and constant term in another side. So write here, therefore x cube upon y cube is equal to 5 in bracket 1 plus k, and we transfer this 7 and 1 minus k to right hand side. So 7 in bracket 1 minus k. Now right hand side is constant, so we constant call as a. So right here equals to a sec. So we denote this as x cube upon y cube equals to a as equation number 1 for substituting the value of a in terms of x and y. If we differentiate this x cube upon y cube directly, then we have to use quotient rule. So we transfer this y cube to right hand side. So we get here a into y cube is equal to x cube. So differentiate this with respect to x. Differentiate with respect to x. We get here derivative of x cube as 3x square. This a is constant. Derivative of y cube as 3y square into dy by dx. Now further we have to differentiate this with respect to x because we require d2y by dx to here. So replace the value of a from equation number 1 as x cube upon y cube. So right here, first we cancel this 3, then x square is equal to, we replace the value of a by x cube upon y cube into y square into dy by dx. We write the value of a from equation 1, so you write here reason from 1. So here y square get cancelled with this y square from y cube, and x square get cancelled from this x cube. So we write this as y upon x is equal to dy by dx. We transfer this y to left hand side, this x to denominator. Now we differentiate this with respect to x again. So differentiate with respect to x. Now here we have to apply quotient rule for differentiating this. So we write here x into dy by dx minus y into derivative of x is 1 upon x square is equal to d2y by dx. If you observe this dy by dx, we can replace by y by x here, so we denote this as equation number second. So right here, from equation second, we replace this dy by dx by y by x. So right here x into y by x minus y into 1, we write y upon x square is equal to d2y by dx2. This x get cancelled, so in numerator we get y minus y upon x square is equal to d2y by dx2. So y minus y we get 0. 0 upon x square is equal to d2y by dx2. And we know that 0 upon any number equals to 0. So 0 equals to d2y by dx2. We have to show here d2y by dx2 is equal to 0, and we show 0 equals to d2y by dx2, that means d2y by dx2 equals to 0, hence proved. Now see sub-question 8. If 2y equals to root x plus 1 plus root x minus 1, show that 4 times x square minus 1 d2y by dx2 plus 4x dy by dx minus y equals to 0. So with the help of given part, we differentiate given part with respect to x here. So write in solution 2y is equal to root x plus 1 plus root x minus 1. So differentiate with respect to x. Now derivative of 2y, we write 2 into dy by dx, because 2 is constant, we have to find derivative of y. Then for right hand side, we have to apply addition rule, derivative of first term minus derivative of second term. Here both terms are in composite form, so we first find derivative of outer function. So derivative of this outer function is 1 upon 2 root x plus 1. Then we find derivative of this x plus 1. Derivative of x is 1, derivative of 1 is 0. So 1 plus 0 we get 1. So we not write that value. So we write directly 1 upon 2 root x plus 1 plus 1 upon 2 root x minus 1. Derivative of this second term, we write 1 upon 2 root x minus 1. Then again we have to find derivative of this term in root. Derivative of x is 1, derivative of 1 is 0. 1 minus 0 we get 1. So we will not write that 1 here, because after multiplication we get the same value. So we transfer these 2 to left hand side, taking 2 common, or we cross multiply this. So we first take 1 by 2 common here. So write 1 upon root x plus 1 plus 1 upon root x minus 1. So cross multiply here in bracket. So we transfer these 2 to left hand side. So get 4 into dy by dx is equal to, after cross multiplication we get root x minus 1 plus root x plus 1 upon this root x plus 1 into root x minus 1. We get here root x plus 1 root x minus 1. So write root x plus 1 into root x minus 1. Now if you observe, this numerator root x minus 1 root x plus 1 is same as root x plus 1 plus root x minus 1. That means we have to replace this numerator by twice y from equation number 1 here. So write in numerator 2y upon, we can write this both the terms in one root, because these two roots are in product form. So write in root x plus 1 into x minus 1, that we write 2y upon in root. We have to apply a plus b, a minus b form. So write x square minus 1 square, and we know that 1 square is 1. So we write 2y upon root x square minus 1, which is value of 4 into dy by dx. Now we transfer this root x square minus 1 to left hand side. So write here 4 into root x square minus 1 into dy by dx is equals to 2y. So we cancel this 4 with 2 and we have to find derivative. So we make square of both sides. So write here squaring on both sides. So we write here square of 2 is 4, square of this root is x square minus 1, square of this dy by dx, we write dy by dx its bracket square and derivative of y as y square. Why we write this in x square minus 1 form, not in root form, because we require answer in root x square without root. So we take square on both sides. Now differentiate this with respect to x. Differentiate with respect to x. Now 4 is constant. We have to apply product rule here. So you can keep 4 common, or you can write 4 with this first bracket. So write here first function into derivative of this dy by dx bracket square. So 2 into dy by dx bracket raised to the power 1 into derivative of this dy by dx, we write d2y by dx2. So first function into derivative of second plus second function, that is dy by dx its bracket square into derivative of first. So we write 4 as it is, derivative of x square minus 1, we write twice x, derivative of 1 is 0, so write 2x minus 0 as 2x. Then derivative of right hand side, so derivative of y square we write 2y into dy by dx. Now if we observe the terms, here we have dy by dx, here also we have dy by dx, its bracket square, here also dy by dx, that means we have take dy by dx common from left hand side. Also we take 2 dy by dx common from both left hand side. So we write here 2 into dy by dx in bracket, here we write this 4x square minus 1 into d2y by dx2. Then we take dy by dx common, 2 dy by dx common, so we write here 4 into x. So write here plus 4 into x, because we take 2 common, dy by dx common, so 1 dy by dx is remaining here. So dy by dx is equals to 2y dy by dx. Now this dy by dx and 2 get cancelled, left hand side 2 comes in right hand side. So we write here 4 times x square minus 1 d2y by dx2 plus 4x dy by dx, and we have to transfer this y to left hand side, so as to write minus y. So we write the remaining term here 4x cube minus 1 d2y by dx2 4x dy by dx, and we transfer this y to left hand side, so we get minus y equals to 0, hence ruled.